All right, you guys are good students. You're watching this. This is the last of the example problems. You're going to be happy though because I'm going to show you something that everybody else isn't going to know. All five of you, or I don't know. Okay, so the first part is just a force times time problem. Force time is mass, change in velocity, right? What's the exhaust velocity? So delta V must be what we don't know. And it's burning 0.0143 kilograms every 1 second, right? And the force is 11.80. Okay, so this is simple enough, right? I'm going to go 11.80 divided by 0.0143, and I get 825. Delta V is 825 meters per second. Okay. The second part of this is if you've got the mass, what's its initial upward acceleration? Well, assuming this is taking off from Earth, we now have, a rocket. Gotta put the fins on it, right? The force up is 11.80 newtons, right? The force down is going to be the weight of the rocket, right? So 0.139 times 9.81. Right, so the force down, 0.139 times. The force down is 1.36359 newtons, right? And now we can set up our F equals ma, right? 11.80 minus 1.36359 equals, what's our mass? 0.139 times A, and now we're all set, right? Okay. Okay, divided by 0.139. And I get A is equal to 75.08 meters per second squared, okay? The only thing you're going to see tomorrow that's not just as hard as this is that if that's its mass, and then we knew how much fuel it had, at the very end of its burn, it's going to have much less fuel, or it's going to have much less mass because it's burned some fuel. And so you got to figure out the new mass, and then that changes the weight and the inertia mass, right? But we'll work on those.